Hello, good afternoon to everyone, and welcome to this HTAi Information Retrieval Group webinar. My name is Rocío Rodríguez, and I have the pleasure of serving as chair of the Information Retrieval Group. We are delighted to welcome Dr. Farhad Shokraneh, who will be presenting on responsible use of AI in evidence synthesis, filling the gap between research and practice. Dr. Shokraneh is an evidence and information scientist with more than 20 years of experience in evidence synthesis. He has held roles at the Universities of Bristol, King's College London, Nottingham, Cambridge, and Oxford, and holds honorary positions at the University College London. In 2016, he founded Systematic Review Consultants Limited. I would also like to highlight his outstanding contribution to empowering the evidence community of practice through his work and free sessions on the responsible use of AI and the automation of evidence synthesis and systematic reviews. His commitment to capacity building and knowledge sharing has greatly benefited our global community. Before we begin, I would like to remind everyone that you are welcome to share your suggestions for future webinar topics or submit questions for Dr. Shokraneh in the chat at any time during the session. Please join me in giving a warm welcome to Dr. Farhad Shokraneh. Thank you very much, Farhad, for being with us today. The floor is yours.
Thank you, Rocío. Hello, everyone, and welcome. I welcome all 400 participants from across the globe for joining us. Thank you for your time, and I hope that there will be something here for all of you. It's very exciting times we are living in. There's lots of new tools coming along, and we hope that you could learn about these tools and use some of them in your practice to serve the patients and the healthcare professionals. Okay, I'm just going to start with a bit of terminology because I think this could be confusing for many when we are using words like artificial intelligence, machine learning, cognition, neural networks, and hallucinations, because these are the things that we usually use, the terminology we use for humans. The computer scientists have been very good at advertising what they are doing, and they've started using this terminology to make them easier to understand for the lay user. So when we are talking about intelligence learning in this context, it is very different from the way that it works in humans. The reason that we are using this is that we don't have any alternatives. So when we are talking about learning or intelligence or cognition, it's mimicking the human behavior, not exactly repeating it the way that humans do. So that is something to remember. And also, there are confusions about when we are talking about artificial intelligence. There is a lot of confusion because for decades, what we've been told about artificial intelligence is no longer true since almost 2022, because we've been told that the robots are going to take the world because they are rule-based, they are following the regulations and rules, and they don't go there is no deviation from these rules. That's why if they realize that humans are ruining the world, they may take over and get rid of humans, for example. So this is based on the traditional rule-based approach to the artificial intelligence, that AI and machines can only follow the rules. And it was true until 2022, almost 2022, that the large language models came along. Before that, whatever AI we were talking about, it was usually referring to machine learning based and data science based. So the machine was learning from the data sets that we were providing and the human's decision on those data sets. And then based on that, they were making predictions about the new data. So when we were screening a lot of patients, we had a lot of images. Based on that, the next image that you were giving to machine could learn from the data that already given and decide if this patient has certain condition or not. And that was when Topol's review published that it says that actually this sort of predictive or discriminative AI is going to replace dermatologists, radiologists, and pathologists, because the computer vision can actually do better than humans with less error. So while it is still true and this sort of AI still develops, we have a new type of AI called generative AI that has started almost, it became a hype since 2022 with the free release of ChatGPT. And that is a completely different type of AI. And the models in there have already been pre-trained. We could do some tuning on them, but the training has been done, and we could only just prompt and instruct this sort of AI to do tasks for us. So if the pre-2020 AI was coming for the radiologists and pathologists and the diagnostic imaging, I would say that the generative AI is coming for the GPs and the general practitioners more, because the way that they have been built, they are helpful in giving the answers. I don't say that the answers are correct, but they're providing answers that usually people have to go to their GP to find out about it. Now, many people are using this. And sort of it will decrease the workload for many people, because many people now, many doctors, because many people are now using this sort of technology for taking medical advice, investment advice, career advice, and all sorts of other advice. So that's something. So the AI that we are talking about since 2020 is not just about discriminative AI, which is established, but also is generative AI. And I'm gonna refer to each one of them during the presentation. The second confusion is that we said that there are things that AI is unable to do, like the emotional intelligence, understanding people, talking to people, providing even sort of therapy. And then the other one was that the technologies are using one type of AI. So people used to say that ChatGPT is large language model. ChatGPT is using large language model as one type of AI, but it doesn't mean that it cannot use others. Or Covidence, for example, or Rayyan, or nested knowledge, all of the tools that you know in the field, they are not using one type of AI. They are using multiple different types of AI. And it is something to remember that we couldn't say that this tool uses just this type of AI. And when we refer to the tools, we're usually referring to multiple features in them, not just one feature. So large language models can do things that breaks the stereotypes that we had for the artificial intelligence. They can make sense, they can understand context, they can do causal reasoning, they could be aware of the cultural and ethical context, provide emotional intelligence and emotional support, they could help you make ethical decisions, and so on. And there are things that they are not good at. I mean, I've said can't on this slide, but it doesn't mean that they can't do it. One is fast information retrieval. They have not been designed to do in the information retrieval or search. So the large language models are not good for searching. There are tools that are using large language models alongside other technologies to provide information retrieval. But themselves, large language models are not good with information retrieval, with statistical pattern recognition, with consistent rule application, with correlation analysis, and with extraction on a scale, like a lot of a big file, a big text file, or hundreds of studies, let's say. So what is interesting here is that whatever we say that large language models are not good at, the discriminative and predictive AI that we had pre-2020, they are good at them. So they can help with the information retrieval. We have Boolean logic. They can do with the rule application very well, and they can extract the data in mass scale. So strangely, these two AIs could complement each other, because there are things that discriminative AI can do better. And there are things that large language models may not be good at, but we can push them. One is purpose-driven inquiry and then critical verification, like risk of bias assessment. So as you can see, most of the things that we are interested in, like consistent rule application for inclusion, exclusion criteria, are not sort of features that large language models are very good at. We could prompt them, we could instruct them, but they are not necessarily really good at them because they have been built to generate, to be creative and create new content. But it is not written on stone. Things has changed and these models are developing very rapidly. There are also some confusions with the systematic reviews. So you may see a lot of videos on YouTube saying that, for example, this tool Elicit can do systematic review or SciSpace can do systematic review. So I wanted to clarify that these are claims, firstly. The second thing is that all systematic reviews are not the same. So we follow a systematic process. At the end of the process, the product may be called anything, like a systematic review, a literature review. It could be called a scoping review, mapping review. So some people confuse the process with the product. So just because you are doing systematic reviewing, it doesn't mean that the end product is going to be called a systematic review. And many people who are providing this sort of confusions, they haven't done a single systematic review in their life, leave alone using AI for doing them. So please be careful of saying that this tool can or cannot do this work. Another confusion is that the using AI in systematic reviews is new, which is not. I just mentioned that we have been using AI, discriminative AI for 15 years. And the AI that is new is the large language models. And the third myth about the systematic reviews is that doing systematic reviews is easy. And I don't need to explain much about that. This is the process of systematic reviewing. Just wanted to clarify to the audience that we follow this process, not all the time exactly same, following the exact same protocol, but it is generally the way that we have to construct the process of systematic reviewing. The end product, depending on how we have followed the systematic review, how broad our question was, could be varying based on the purpose, the question, the data. So if we try to scope the literature and see the big picture, we have scoping reviews, mapping reviews, evidence gap map. If depending on the mode of the systematic reviewing, we could have rapid or living reviews. Depending on the data type that we have, we could have mixed qualitative meta-analysis, IPD meta-analysis, or network meta-analysis. Depending on the type of study designs included, we may have integrative review, umbrella review, which is systematic review of systematic reviews. We also have realist review, which has a systematic review component, but it will have a qualitative component as well, like interviewing the experts and patients. And then depending on organization and the conducting guideline that you follow, we will have Cochrane review, Camper review, JBI. Depending on the question that you are answering, you could have interventional, diagnostic. And then there are types of literature review that we have no guidance on conducting or reporting, such as targeted literature review or state-of-the-art SOTA. That you can do whatever you want and call it targeted literature review or SOTA. There is no guideline, so all of the literature reviews are targeted. I don't know why we should call some of them targeted. So let's get to the first stage. So for the question finding and refining questions, some of the large language models are helpful, and I will give you one example later on. So if you have a research question, or if you don't have a research question and looking for an unpublished systematic review, large language models can give you ideas. And that's not always true, but if you check, probably from out of 20 ideas, half of them will be ideas of unpublished systematic reviews. So it is one way. Another way is that giving this research question to large language model and asking to clarify it, detail it, expand it, or limit it. And these things are really good. Large language model based technologies are helpful in that. But the discriminative AI that we had before that, they were not particularly useful. So the second stage, after having your question and writing your protocol, and in protocol write-up as well, the large language models can be helpful because they are good writers. They have read a lot. That's why they are good writers. But the human verification always is required. For the search, I think it is important to have a typology for the search, because I haven't seen it in the literature. Many people, like practitioners, may get confused with different types of tools. We are familiar with Boolean search and or not, and we've been using Boolean search for, I think, probably 5-6 decades. But then there was a new type that was very popular in the last 5-6 years called semantic vector search. And that assigns the numerical value for the words, and based on this mathematical modeling, could predict that how much each document matches the search query. And they are very good. We've been using them frequently, and we still use them. And then there is hybrid search that uses two of these Boolean and semantic vector search together. Each one of them have their own advantages and disadvantages. But then recently we have something called agentic search, and using agent as AI, like your estate agent when you want to buy a house, rent a house, or sell it. So you are using AI as an agent, and with the agentic search, what we mean is that using AI to do a multi-step work. So you ask the question, you send the AI away, it goes into the literature, search them, screens them, extract information from them, summarize them, and present a report. So it is multiple tasks done automatically, and that is called agentic search. That now we have multiple tools that are providing it. And then there is citation network search that also are not new. We have had it for about at least 7-8 years. They are popular as well, and they could find the relevant literature when there is a seed paper. So when you finish your systematic review, you have 10 papers that are included. Using these tools that are based on citation network, they could identify more relevant papers. So it is important to remember this, and to investigate the tools that you are using to see which one of this type of search they are supporting, and what are the advantages and disadvantages of each one of them. Also, Aaron Tay has presented this sort of classification, because some of these systems say that we are providing deep search or deep research facilities. So what Aaron did is to classify these two separately, to say that what is the difference between deep search and deep research. Usually, deep search, we are looking for more of papers and not the answers, but in deep research, we are looking for the answers, a report at the end, the list of papers that have provided that answer, and usually takes longer. So that is also something to remember. I put the link to Aaron's blog post about this. I think you will find it useful at the end. So Undermind.ai is one of the tools that I think made a lot of noise. That is still my favorite tool, even though it is not open. What it does is agentic search. So as you can see on the right-hand side, it shows the process of search. There is iteration. It might be 2 or 3 different search runs that the system conducts, and eventually gives you a report with the references in it. So I use it mainly to identify the relevant papers for, like, as exploratory search, to find the relevant papers when I'm beginning to design the search. So I could use this set of papers that I identify as test. And it is not the only way that I use, because it could be biased. So I'm using multiple methods to identify these seed papers to test my search against. But it is, if there is one tool that I would recommend you to try, is this one. It provides 5 free runs for you. Don't waste them. Think about which one worth it. So it is 5 per month, the free version. Obviously, if you create an account with another email address, you could have another 5, and you could have like multiple email addresses and use a lot of free tries. So using this sort of AI, large language models, even machine learning, it is important to remember that the input quality is very important. The file that you are putting inside these systems. So what you see here is the 2 different exports from ClinicalTrials.gov. The left one is the RIS format that I got, and the right one is the CSV format. So RIS format only has title, which is very useful for screening and deciding on the relevancy. What you see on the right-hand side is providing a lot more data, including the summary and entire PICO information in detail. So if I export the results from ClinicalTrials.gov as RIS format, what happens when I put it in Rayyan is that I see the title. There is no abstract. So the discriminative AI that we have been using for 15 years, they work best with the standard records like journal articles that have title and abstract. So this is the record for a review that I was doing, and I was interested in randomized controlled trials of schizophrenia. As human, you can decide that this is relevant, but as you can see, the rating that Rayyan has given to it is half and half. So I cannot decide because there is no abstract. So strangely and interestingly, if you give this record to large language models, they will be able to make a decision on that. So that is something to consider, that if you could combine these two types of technology together, they could do tasks that on their own they are not capable of doing. But again, human judgment, as you can see, plays a great deal in these tasks of screening. And the quality of input file is very important. Garbage in, garbage out. So this is another implemented discriminative AI in Covidence. You could use relevancy ranking, similar to Rayyan. You could use it in Covidence. It is, I think, available now in every single automation tool. Laser AI, PICO Portal, all of them provide this ASReview. As you screen, there is active learning happening. Machine learns from you and sort the records based on the relevancy and shows the most relevant one on top. This is a progress graph from ASReview. So if you have, let's say, 5,000 records and you randomly screen the records to find the relevant ones, to find all the relevant records, you have to screen all 5,000. That is the random stair style graph that you see here. But if you use the priority screening, which means as you screen, the machine learns from you and present the most relevant records to you to screen first, you could have potentially stopped at 600 records. That's a lot of resource and time saved. This sort of priority screening exists in multiple tools like API-Reviewer, like ASReview, PICO Portal, and there are many tools. I couldn't name them. There are tens of tools. But it is very important that you know that this sort of discriminative AI that we were using is still really important and really useful, and large language models cannot do this. So the generative AI can't do it as good as what we already have. If you look at PRISMA 2020, there is also another option, says that records marked as ineligible by automation tools. It means that there is acceptance that in certain types of systematic reviews, records can be marked as ineligible by automation tools, and we could report it in PRISMA in our systematic review. So it is part of the reporting guidelines already since 5 years ago. How we can do it? For example, in Covidence, if you are doing a systematic review of randomized controlled trials, there are two options. One says that get rid of the references that are not randomized controlled trials, because using Cochrane RCT classifier, we can do that. And then the second one is that tag the references reporting an RCT. So if you use this option, the records will say possible RCT underneath them as one of their tags. We have used these features in a real review, and what we got was that we automatically got rid of 2,423 records that were not randomized controlled trials. And we are going to report it exactly the way that PRISMA said. We are going to say that the automation tool identified them as ineligible. So what you see here so far is that we have also duplicate records removed. So the removal of duplicate records, automatically finding PDFs in EndNote are examples of rule-based automation that does not involve machine learning at all. So we have automation, we have rule-based automation that does not use machine learning or large language models. Then in the same screen, we have auto marked as ineligible. That is the discriminative AI machine learning that we have had for 15 years. And then if you go to the data extraction section in Covidence or Laser AI, you would notice that they are also using large language models to suggest the value for the data, for the fields in your data extraction form. So in one tool, you can see rule-based automation, machine learning, and large language model. So it is very important to know that these features exist and each one of them have their own advantages and disadvantages. As long as you know that, and as long as they have been implemented within one of the automation tools that you already are familiar and using it, you should be safe to use them. And so when to stop screening, however, it is not set. So stopping rules, we don't have a single stopping rule, but there are multiple ways of looking at it. I think I really like this from Scotty's paper that published, I think, a couple of months ago. And I wanted to say that there are many ways when to stop screening. I would say even if you decide to stop it, at least one reviewer, it's better to check the remaining records. So if you are using priority screening and you screen 1,000 records and then you continue screening but you are not finding any relevant records, you may decide to stop at some point. There are multiple ways on when to stop, multiple methods that you can follow. But if you decide to stop, I recommend that you ask at least one reviewer to check the remaining records. So rather than double screening, you could switch to single screening. Let's go to the risk of bias. So for the risk of bias as well, we have had RobotReviewer for, I think, at least 6-7 years. RobotReviewer still exists, and you could assess the risk of, it could do the assessment of risk of bias for 4 domains of risk of bias tool that Cochrane provided, the first version. So let's have a look to see how it works. So this is RobotReviewer. I'm going to desktop. I upload one paper, which is randomized control trial, and ask for the risk of bias assessment. And while it is working on it, at the same time, I can actually ask Copilot that I'm using, which uses GPT-4, I think. And this is the organizational version. I'm going to say assess ROB based on Cochrane ROB1 tool for this RCT. Then I'm going to add the same PDF, and that's it. So RobotReviewer is still thinking. I don't think it should take this long. Probably it is busy. But large language model is done the work. And then it shows me different domains. So I could say that tabulate these results. Maybe it's done it already. Yeah, it's done it already in a table. But yeah, you can see that it is done work and it could actually make it in a downloadable format. But it doesn't mean that it has done it correctly. So it has collected, for example, here it says for blinding, it says high risk. And it says that the intervention, the participant were not blinded to intervention, but one of the intervention was exposure to sun. I don't know how you could blind participants to that. So I wouldn't say that it is high risk. I need to look at the paper, obviously, but you can see that just because it finds the information from the PDF, it doesn't mean that it could also have a good judgment. It also provides the Excel output. You could do a lot of things here. And what you see here is not just large language model. It is called orchestration. So when you ask a question and you get an answer, that is called inference. But orchestration is that the systems can use multiple tools, do multiple tasks at the same time. It may take longer. So for example, you could ask them to get the data, do the meta-analysis, present a forest plot, and then put the results of meta-analysis in Excel file as well. And it uses the functions that does not exist here in the system, but from external sources to do the work for you. That's called agent. So it is AI agent that doing the work. But anyway, so it has done it. I just RobotReviewer still thinking, but I wanted to show you that the RobotReviewer does similar work, even better for the old version of Cochrane risk of bias tool. But this one is using machine learning, and this is large language model. And you can see that both of them are good, almost good for doing the risk of bias, well, extracting the data about the risk of bias. So the issue with both of them would be that how do I know that they are right? Then I have to open the PDF and look for the information. But seeing is believing. As long as you can see where in the PDF is the information related to that risk of bias domain, that is the perfect use of large language model. So PICO Portal provides that option. Now I know that Laser AI provide that option as well, some of the other, but PICO Portal was one of the first that implemented this. And so you upload 20 PDFs, you choose the tool that you want to use for the assessment of risk of bias, and the rest is automatically done. Even the answer, the suggested level of risk of bias have been listed there. You can change it if you want. So you click on the randomization item, it automatically opens the PDF, automatically scrolls down and automatically highlights the section. It's also called attention map. And then you could decide if it is correct, or you can change the answer. That is the perfect implementation of large language model within the existing automation tools. And that is something that you should be comfortable using. So when you say, if I should use large language model, if it is like this, implemented within the tools, why not? Because they are suggesting you are approving their suggestion or changing it. So you just saw 3 different types of using AI tools, RobotReviewer, large language model, and PICO Portal, which is embedding large language model within the existing automation tools. So for data extraction, one of the classic problems that discriminative AI had was the 2-column or 3-column, or in case of Lancet, multiple column PDFs. And the end of the line wasn't always clear, and people complained that and I still do, that the PDF is the worst thing that happened to OpenScience. So in this case, the discriminative AI would read that don't dead, open inside, and you open inside and you are gone. But large language models and the better discriminative AI that we have now, they could read it correctly, that it says don't open dead inside. So that is from Walking Dead movies, a good example of the problems that the classic AI had dealing with data extraction. But I have been using large language models for data extraction, and I found them useful for saving time. I wouldn't comment on the accuracy because I don't think that they are accurate and you need to check them. But I have some comments and suggestions that you may find useful. Firstly, try to use specific instructions. For example, when I said assess risk of bias to Copilot, I should have said tabulate risk of bias. Quality of PDF is important, as I mentioned. Garbage in, garbage out. If your PDF is not of good quality, don't expect a miracle. And if you want to find out if it is good, just try to copy it or export it into Word document or TXT. And if there is no error, then good. Actually, it is better to convert your PDF into docx correct it if there is any correction, even recreate the tables, columns, and they spend a bit of time and then feed it into the machine, which will be time consuming. So it may not work for data extraction if you convert it to docx, but it will work for translation better if you could do that. And there is always the possibility of error. So you always should have zero trust in the systems. If you are having more than one PDF, make sure that you either upload all of them or merge them into one PDF file. If there are discrepancies within the PDF, so there are mistakes by the authors, large language models usually cannot detect them. If you bring it to their attention, then they would accept it. They will say that, yeah, you are right. But they usually don't detect it, and they will get the first instance of occurrence as the correct one. So if in the abstract there is a mean and the standard deviation that is correct, and then there is in the table, in the text that is not correct, it will report the correct one in the abstract. But usually the abstract one is not correct, and the one in the table is correct if you contact the authors. So factored cognition is helpful. So don't upload too many PDFs. In my experience, when you upload one PDF and ask for the data extraction from, let's say, ChatGPT, Copilot, that are using GPT-4 or 5, they work okay. But upload 5 PDF and they start making up things. So I was doing work on a skin disorder. I uploaded 5 PDF that were about that single skin disorder, and it extracted data for all of them and reported the condition, different skin disorder for each one of them. So it created 5 different skin disorders for me, which wasn't correct. So it is important to ask for bite-sized information, requests, and break the long procedure into tiny micro tasks, and then use the large language models if you are using chatbots in particular. They are not good with the data in figure. There are other tools online that can extract data from the figures and images. I would say that be very cautious. Whenever large language model-based systems cannot find the answer from the PDFs, they will either look for it somewhere else or they start guessing and making guesses. And sometimes that you want data, they may start getting the data from discussion and introduction rather than methods and results. That is also something to remember. Use the version that your university or a healthcare system has approved. So I'm using the version of Copilot from Bristol and the version of ChatGPT from Oxford University, because they are copyright compliant and you have more control over it. Majority of the large language models now are using RAG, retrieval augmented generation, which means that you could connect their capabilities to a data set, a PDF, or a database. So they will not go all over the place to find the answer. They will find the answer from the database or data source that you have connected to the system. And just because their version is going higher, it doesn't mean that they are going to perform better. So you need to make sure that you have tested them before moving to the higher version of these models. So this is an example of a meta-analysis that I created. I gave the data to Copilot and asked for a meta-analysis. Didn't say even what effect measure to use. It did it correctly and reported it as a forest plot as well. What is problematic here is that the last line says that in the explanation, the red marker at the bottom shows there is no red marker at the bottom. There is a red marker on top. I don't know why there is numbering in this graph, 1, 2, 0, 1, 3. But anyway, it did the calculation correctly, gave me the risk ratio correctly. But yeah, you can see that the graphics are not good. So if you ask me, should I use it for meta-analysis? I would say that there are so many free rule-based tools, automated rule-based tools and the statistical packages that produces even better images and figures, and also more calculations, statistical information that you would need, that it is better to go with the existing packages. If the existing packages use large language model in them, that's fine. There are guides how to use these large language models for the statistical analysis. I could share with you if you were interested. But generally, I would say that things that are so rule-based, so mathematical, and so binary, it's better that we go for the rule-based technologies like SPSS, Stata, R to do this sort of work. But still, if you are experimenting, if you are testing the work that you've done already is correct or not, then why not double check with large language model to see what you are getting, and it is fun. For prompting, because it is important, you are speaking the language that they could understand, the large language models understand. That's called prompting, or how to write the instructions for them to do the tasks. And there are two recent suggestions coming up from the literature that I put here, how to do the prompting, how to test your prompts are working well, or so-called, some people call it prompt engineering. I'm sure those some people, some of them are computer scientists, they just want them to look more attractive for the audience. It is just how to instruct the machine to do the tasks for you and how to test that it is done it correctly. There are literature that have discussed it, obviously, and I've cited it. I hope that you could at least find time to read some of them. But when using AI, consider this: garbage in, garbage out. So when we were using machine learning, classic ones before 2020, and currently we are using it as well, we say that human expertise or human teacher is important because the machine is going to learn from you. If I'm a rubbish screener, I'm just going to create a rubbish machine learning model that is going to give me the rubbish ranking. So that is very important. Quality of the records and reports is important. In case of large language models, quality of prompts as part of input is also important. So learn about the prompting, and the best way to learn it is to do it, just using the systems. The inevitable condition for using AI is that human check is inevitable. There should be there always. Human is going to be the final responsible person for the output, whatever happens. Try to document and report it in a reproducible way, including your prompt, the version you used, when you used it, what was the outcome, did you test it, and all the details. I know that many people are going to use it and not report it. We cannot stop people. We could just tell people what is right to do. Follow the best practice conducting and reporting guidelines that already exist, like Cochrane Handbook, like PRISMA 2020. I think they are good enough still, telling you how to report the automation when you used. AI is automation, machine learning is automation. So you could actually use these tools and follow the existing guidelines still. Have zero trust, never trust the machine until you check it, and choose the specific tools. Don't go for the chatbots for everything. I find, for example, chatbots for the data extraction just to save time. Even when you check it, you probably think that if I was doing it manually, it would have taken the same time. So it's not all the time saving, but I think it saves you the time of Control F, copy and paste. You just spend time on looking at the PDF to verify all the content. If research says it works, it doesn't mean it's going to work for you. Research is done in controlled environment, done by multiple members of team who are really experts in what they are doing, either in AI, LLMs, or systematic reviews. And it may take them 6 months to do that research. And you may not have 6 months to validate the work that you are doing. And the things change since they've done the research, obviously, the systems develop. And assigning a role or a context to large language model before starting to use them is helpful. And currently, Copilot and ChatGPT allow you to create your own version of GPT or MyGPT, and you could create multiple of them for each task. So what AI to use? That is the question that many of our students, colleagues, and clients ask us. I always recommend them to continue using AI features within the existing systematic review tools. So it could be Rayyan, Covidence, Distiller SR, ASReview, Nested Knowledge, PICO Portal. I'm just dropping names here, but you could name tens of them that have implemented machine learning or large language model, or both of them. And as long as human reviewer checks them and human is responsible, they are safe to use. And this is the best recommendation I could make. Because in all the time, even large language model, what they provide is the suggestion. It is not the final decision in terms of risk of bias data extraction. And LLM as an assistant or one of the initial reviewers is okay, I would say, not a senior reviewer who makes the final call and takes the bullets or responsibility. When using large language models, if you want them not to make errors or hallucinations, is to ask them to give the quote or section from the text of PDF. That way, you could actually save a bit of time, even though you have to open and check the PDF that quotation exists. If asking for the calculations, ask large language model to show their working or how they did the calculation, and how and report it. Even there is a formula, report the formula. Where did they get that formula? And that is all important to make sure that there is no errors or hallucinations. And repeat the same task in multiple different time points or multiple large language model based systems to check the reproducibility. So you have controls over large language models that your organization have provided for you. You could inactivate the memory feature. There is archive feature, there is learning feature that you could inactivate or activate it. There's personality feature. There's temperature setting that you could use in prompts, within the prompts. So temperature in this context means the randomness and creativity of the system. If you set it lower, they will be more conservative. If you set it higher, they will be more creative in their writing and answers. There are 2 studies that have used it, and they exist on the living map that I created, and it is open and free. So learn about prompt engineering. You could create your own agent, and large language model-based chatbots can be connected to the other apps. So just to give you a brief overview of what you can do. So here is the ChatGPT I'm using from University of Oxford. There is a setting. If you click on your name, there is a setting, and in that setting, you could do a lot of work, a lot of things. Personalization. You could choose a personality for your bot, and there are data control, security, and all sorts of things. But also there's a section called GPTs. So you could have more than one GPT. You could create your own GPT, and you could have my GPTs. So for each task, you could have a context-based GPT. So you have a lot of controls in your settings. It is similar when you come to the Copilot. So I'm using the Copilot through the Bristol University, as you can see. And here also you have options for doing some settings, but also there is I wanted you to see that there is a green shield on top right corner. And if you click on Enterprise Data Protection, it tells you that it will not use your data for training. It will not use organizational files. So it said that we secure your data. Your data is private, access control, and said that your data isn't used to train foundation models. I think it's a good thing to have. Okay, so so it is challenging. It is challenging to use large language models in evidence synthesis. Why? So Siemens correctly have collected and the colleagues. It's one of the best papers that I would recommend people to read. It summarizes everything. Irreproducibility. So these large language models are generative AI. They are good at generating stuff, and they get updated frequently. The oldest versions are not accessible. If I can see here, if I go to ChatGPT, I go to so it is ChatGPT 5 by default. If I open it, there is GPT-5 thinking, and then there is legacy models. So you can see that you don't have access to the model GPT-3 anymore, and there are many studies done on that. So how am I going to use those studies if I cannot check and repeat their findings? And I don't think that in a few years you would see the other models that you can see now. So that is one problem, that they get frequently updated. The old versions are not there. The way that you prompt them can affect the output, so that makes them even more irreproducible. And the research that is done saying that they are good or they are not good, the way that they have been conducted is heterogeneous. We are not following any reference standard or template for conducting research on large language models. We don't know how these large language models have been trained. The data sources, they are not transparent about it. Unlike the discriminative AI, like RCT classifier that you have in a peer reviewer, in Covidence, they have used Cochrane's data to create this RCT classifier. So it's clear, it's been reported publicly, so there is nothing hidden about it. And then there is the contamination bias when validating using retrospective data. Some people say that we use the published systematic reviews to see if AI can find the included studies. So yeah, they can cheat. They can cheat. They could find that systematic review and get the included studies from inside it. They may have been trained based on those systematic reviews already. So there is that sort of bias that research should be usually designed prospectively. The risks of using large language model, and the first one is the most important one, that even though you may ask AI to do the data extraction for you, you may check a few of them and you realize that, yeah, it is correct. I'm not going to check the rest. That is the first part that is danger. The second part is that we want our students to suffer and learn new skills, including critical thinking. And if they continue using large language model-based chatbots for assessment of risk of bias, that sort of skill is forgotten. And in the future, in their career and in their life, they will struggle if they don't know how to critically appraise the claims. Intellectual property, and it is not just about the copyright. It could be plagiarism. You may upload to the free versions in particular. You may upload a document, a manuscript, and ask for comments, and ChatGPT can learn from it if it is the free version in particular. And then you cannot submit it to any other journal because based on their policies, they will not publish something that has been presented somewhere else. So these are the things to consider. But the organizational versions are better. They have set some of these, let's say, policies. They are compliant with these policies. There is no user guidance on how to use these systems. Everyone, I mean, librarians and information professionals have created a lot of guide, but many people unfortunately go to YouTube and there are lots of claims there, lots of financially supported claims. So people get paid to say that this tool is good and great and I'm using it every day for systematic reviews, and those people have not published a single systematic review if you check. Data privacy is important, in particular if you're going to upload individual patient level data for meta-analysis or something like that. Environmental impact is important. There are types of AI called HTAi that are more considerate, like certain versions of Llama large language model or Qwen. They are using less resources. Some of them uses your browser and your computer and the energy, more energy from your computer rather than the cloud under the sea. Algorithmic bias that have already been discussed a lot in machine learning and large language model and cybersecurity. There are ways to hack into the organizations and get their private data using cybersecurity attacks through the prompts. What to do? This is your to-do list. If you're interested in political side, futuristic view, follow Luciano Floridi. Andrew Cox is very good at presenting the librarian's role and information professionals' roles in adopting AI in organization. Julie Glanvin's webinar that presented in Evidence Synthesis Ireland is on YouTube. Definitely watch it. Saved me a lot of time. I excluded a lot of content from my slides after seeing it. Aronte's blog or Substack, Cochrane Handbook, and PRISMA 2020 Systematic Review Toolbox. Justin Clark, an information scientist that has led the best systematic review so far on using large language models in systematic reviews. Definitely have a look at it. Cassandra Gordon, another information scientist, has created AI search tools metrics. The link has changed. I've put the correct link here. Have a look at Ray's guidance, which tells you what to do to be responsible when using AI without telling you how to do it. There is a chatbot assessment reporting tool that I suggest you to look at it. If you use chatbot, try to follow this tool reporting its use. Dean, another information scientist from Canada, has created a wiki. He is into wikis, since I remember. Have a look at it. There are assessment of tools there. I created a living evidence map of automation of systematic reviews that collects all the studies related to automation, machine learning, and large language models and organize them. I have a free private newsletter that you could subscribe. I cannot see your name or email address. You will not receive any ad. My webinars on YouTube. There is only one reporting guideline on AI that ISPOR, I think, reported it, Elevate GenAI. Definitely have a look at it. And if there is one organizational document you should read, is NICE's position statement on using AI in evidence generation. Librarians should take lead. Creating literature courses, tool guides, independent reviews of tools, and they should start webinar series on how to use these tools in research, and they should talk to the tools to improve them. And your homework is spending 5 minutes on the website of these tools and familiarize yourself with these 3 databases. Why? Because majority of the tools are using these 3 databases as their source. And the golden rule and the last slide, if you can't do something, don't ask large language model to do it for you. If the large language model does it wrong, there is no way you would know because you don't already know in the first place how to do it. So you are responsible for the LLM's output, not LLM, not OpenAI, not Anthropic. You are responsible. Double check if you can, triple check. Thank you.
Thank you very much, Farhad, for your insightful presentation. To be honest, thank you for being so generous, sharing all this knowledge with us and making it open. So if we have lots of questions, we have 24 right now. So what do you consider could be only a couple of minutes because we are a bit past 4. So do you want me to order those questions that have more votes and to start with the first one and to have 2 questions perhaps?
Yes, please. And the rest of them, if we could have a list, I could answer them in a separate documents and we could email it to the participants.
Okay, thank you very much, Farhad. So the first question with more votes is the following one. Sorry. Do you consider e-resource licenses before you upload a journal PDF to an artificial intelligence tool?
So for the organizational ones, you don't have to because they have already mentioned that the systems that we are using, for example, Copilot at Bristol and Oxford and ChatGPT at Oxford, they are not using these PDFs to learn. So as long as they don't contribute to the learning of the systems, they are safe. You can upload it. I know that Covidence, Laser AI, and other tools, PICO Portal, they have implemented similar legally compliant large language models. So you shouldn't be worried uploading. The free ones, however, it is the breach of copyright. I wouldn't say that the next day Elsevier is going to knock on your door and gets you to the court. People won't notice it if you use it, but it is not right to do that.
Thank you. The following one is, often the questions I get about artificial intelligence use in reviews come from students who are working on their first review under a supervisor who is not necessarily expert in reviews. They are already on a huge learning curve, learning the method, or they are dismayed that there is a method to learn because they thought this will be easy. I hesitate to recommend artificial intelligence tools because, as you point out, the human needs to know the method and apply their judgment to the tools. Do you have thoughts on this?
Yes. Exactly. So what happens is that when they come to me to say that I want to use AI, and say that definitely use it, and when they say which one, I say that okay, for finding out unpublished systematic reviews and research questions, use ChatGPT. Say that give me idea about, and then when you want to do your searches, use another AI tool. It is called 2D search. It will help you to develop your search strategy. And then there is another tool called Polyglot that will help you to translate it to other databases. And for the screening, there is another tool that is using AI, which is free. It is called Rayyan. Use it. So I don't say that, so they summarize entire AI into ChatGPT. And that is what I say. I say that actually it is mandatory to use AI in your systematic reviews. And these are the tools that you should use.
Okay, thank you very much. And the last one, can you comment on the copyright issues of using full text in artificial intelligence models? For example, PICO Portal showing you the full text. What are the implications in terms of copyright? Thanks.
So they are compliant with the copyright law because their system, their machine learning system is not using these PDFs for learning. So there is no problem with using it within the existing automation systems. What is problematic is using free version of ChatGPT or systems to upload copyrighted PDFs. It should not happen. You should not use the free systems to upload the PDFs because they can actually easily learn unless you do a setting in those systems that stops system from learning from the files that you're uploading.
Okay, only the last one, sorry. Thank you. Does Undermind AI ever hallucinate references? Do you know?
I haven't come across any one of them. I don't say that it doesn't. And the reason that I say that I haven't come across is that I actually use it for getting the relevant papers. And all the time that I've used it, 100% of time, there has been paper. Not all of them were relevant, but I have not come across any, not even once, that it has hallucinated. I know that Google's Gemini does that a lot. It creates the reference that does not exist, or say that this information is from this reference. When you go to that reference, those information does not exist in there.
Okay, thank you very much. So I think it's time to finish the session. So I would like to thank you for sharing all your time and your knowledge with us. And thank you to the audience. And hopefully we will see you soon in a next webinar. And remember to join our LinkedIn website, and we will keep you updated. Thank you very much, Farhad.
Thank you, Rocío, and HTAi Information Retrieval Group for the invitation. Have a good day.
Thank you very much. The same for you. Bye.